This is Introduction to Kubernetes. I'm going to share my screen. So basically what I've done is I've created, can I have chat back? Please, where is chat? There we go. All right. So I've created like a accompanying repo for this. So if you want to follow along, here is a link. Yeah, so what is Kubernetes? Well, it's usually, I think, described as a container orchestrator. So what do you mean by that? Well, it's basically, you have Docker and you can create containers and you can use Docker Compose to set them up and all that. But what happens if you want to scale your application? So I don't know, I guess you could try running multiple instances of it on multiple machines, but that's kind of, especially when you're scaling up to potentially thousands of instances to serve, you know, hundreds of thousands of clients, then that kind of becomes impractical. So Kubernetes basically exists to manage all the scheduling for you. I've kind of put in this diagram that I yoinked from an article, and basically this is like the components of Kubernetes internally. So you have this master and node architecture, and the master nodes typically, they have this thing usually called at etcd, which basically manages the cluster state, and it's synchronized across all your nodes. And then you have this API server. So you have the whole Kubernetes API, and everything communicates with that. So when you're controlling the API with a tool like kubectl, that allows you to manage all your deployments. And then you have on each nodes these different services. So you have kubelet, which basically talks to the API and is what actually creates your containers. And then kubelet will talk to something, it's not shown here, but a container runtime. And that's what actually does the containerization. So, the classic container runtime is Docker. But and so in the past, kubelet would tell Docker to create X container. So instead of using Docker Compose or Docker directly, it'll be like kubelet will speak to Docker over the Docker API and say create this container. But it's kind of, Docker's kind of falling out of fashion for Kubernetes. So a lot of the time, what happens is you create your container using the Docker tooling, since that's what everyone's familiar with. But the containers are actually in a standard format, so you can use another container runtime, which is more suited to running in Kubernetes. So that's what you'll use. And then you also have this service proxy, kube proxy, which is basically responsible for routing network traffic. So I'll explain when you come to each of these components or objects here. That's how you actually get traffic out and also between different deployments. So basically, there is this, you see here, there's this CNI network. So networking Kubernetes, networking in Docker is usually pretty straightforward. It's just a single bridge because you're only on one machine. What happens when you have many nodes and they want to communicate with each other? Typically, you'll have this cluster network. So that is this massive network where every container is able to basically communicate over, no matter what node the container's on. And there's different providers for that, because there's a couple of different ways you can do that. A classic one, it's actually not listed here, but the most popular or most common I've seen is Flannel. It's pretty straightforward. It creates this overlay network which spans over all your nodes, and then you can communicate within the same ISP space no matter where they are. And yeah, I mean, that's a very, very brief overview of the architecture. You can see there's a lot of moving parts here. So actually installing Kubernetes can be a pain in the ass. There've been so many. It's a bit like the JavaScript world. There are many solutions to this actual setting up of deployment of Kubernetes problem. And I'll explain the one we're going to use in a bit. So then I just like to go through each of the actual objects. So we've got our Kubernetes internal architecture, but what does Kubernetes actually give you once it's set up? So everything is basically in these objects, and you describe an object using YAML, which we'll come to, and there's a very standardized spec for what those YAMLs look like. And typically, you'll create an object, and you use that. You post it into the Kubernetes API, and what'll happen is Kubernetes will the object as it exists in the Kubernetes system is the desired state. So you say, I want this application, I want it to be replicated this many times, and I have a load balancer, and then I have some state that's stored in volumes. You say that that's what you want, and then Kubernetes does everything it can in the background to make that the state. And if something's not working, it will keep trying on its own transparently. So that's what's really nice about Kubernetes is whatever you describe in your YAML is the state that you want it to be in. It's not the current state. You can get the current state, but the state that you're describing is what the state that you want. So then the objects, this is a list of some of the kind of more common objects in Kubernetes. The pod is what people usually call the smallest unit of Kubernetes. So, or the smallest compute unit, I suppose. And the reason it's pod and not container is because a pod can actually be made up of a number of containers. This is this kind of, I think it's not really shown here, but this group of orange boxes is probably what they're trying to refer to as a pod. So in a pod, it's basically a very tightly coupled set of containers. So they're always deployed together on the same node, and they also, I suppose, the defining feature of a pod is they share the same network namespace. So while they have different file systems and they can be completely different images, if you look at the IP address inside the pod on each container, it's actually the same. So the most common, most of the time a pod will only have one container because it's one app or one part of the app that you're deploying, and it can be different parts of it can be on different nodes and they can be communicating with each other. But in some cases, you might have what they call a sidecar, where you have, your main application. Let's say it's, I don't know, some web app that you've written. Then you might have a metrics collector or something like that. And you'd want that to be, sitting on the same node right next to the application itself. And then it would collect those metrics and send them out from the same network space. So that's why you have this idea of a pod instead of just a container, as you would in Docker. And then deployment is so you can technically create a pod on its own, which you'd never really want to do that because then you're kind of managing each instance. So a pod is kind of about as far as you can go in Docker Compose, except you don't have that idea of multiple containers. A deployment is actually something that will manage your pods. So you create a deployment which has a specification of the type of pods in that deployment. And then you say, I want X number of instances of the pod, and the deployment will create that many instances, and it'll try, again, it's this desired state. So it'll create, if you say you want 3 replicas, then it'll create 3 pods and make sure those are up and ready. And if a pod fails for some reason, it crashes, then it'll automatically create a new pod in its place. And it'll also make sure, let's say if you do an upgrade, change the image, then it'll make sure that all of the new pods, there's one pod at least in place. It depends on the strategy you use, but usually what will happen is, let's say you deploy a new version of the image, it'll make sure at least one pod is up and available before it switches over, which one is on the back end. Then you have config maps and secrets. So this is typically how you would do configuration in Kubernetes. So this is something that's, again, doesn't exist in Docker or Docker Compose land. You'll have, your configuration for the app, like whatever kind of app configuration you might have, or secrets like passwords or API keys or whatever. And those basically go into a separate object. And the reason you want to have it that way is because you can make changes to the configuration without having to, create a totally new image or new deployment description. You can have your pod, reload the config without having to actually redeploy the entire application. Then you have this service. So a service is how you actually get traffic from outside your cluster in, and also between different deployments inside the cluster. So when you have a deployment, it has a bunch of pods, but you don't have any association or way to reach those pods directly. Well, I mean, you technically can, but it's like a more in a kind of a debugging sense. If you have, let's say, a database application and then a front end web application, then you want the web application to be able to talk to the database. So you would create a service in front of that, and that so every pod gets its own IP address, and a service then gets is this object that gets its own IP, and it acts basically as a load balancer. So service will basically point to a set of pods, or all the pods in a deployment, usually. So let's say I have a pod that exposes, HTTP, and it's on, this is in a deployment. So let's say I have 3 replicas, each has their own IP. Then I create a service and I say, point that at all the pods that match this specification. Usually you'll have like a label so that you can match them. And I'll get to all this later. But basically then the service will internally inside the cluster, there'll be a DNS entry for the service. And when you try and hit that, usually it's just one IP and not the individual backends. You can configure it. But basically what will happen is I'll create a database service with the database network port. And let's say I was using a database that supported multiple, failover, or it supported load balancing. Then when I hit that IP address, the service will transparently balance between the services that I have, and there's different ways you can configure it. And then in terms of actually, you can expose things externally too. So there are kind of a number of different types of services. There's a cluster IP, which, as I was just explaining, is just another IP address inside the cluster that can be resolved by other applications. You have a node port, which basically says, for every node, expose this port, and then if you hit any of the nodes, you'll get traffic tunneled through to that service. So node port is kind of, I'm not sure if it's deprecated, or I don't know, it's not deprecated, but it's typically not the way you'd actually want to run something in production, especially a web application. You want to run it through Ingress. And there are also a load balancer type service, which is pretty common then. So a load balancer basically says, it's really kind of generally in the sense of a public cloud, where you say, give me a load balancer, give me a public IP address usually, and then any traffic coming in to that public IP address gets load balanced across all of the backend pods. And then Ingress then is basically, it's newer, and the idea is you have, HTTP traffic, but you might have many HTTP services. So Ingress is basically you have your cluster. Usually, if you, let's say you have a HTTP application, you create a service for it, and you'll just make that cluster IP, and then you create an ingress which points at that service, and that describes, that's basically your virtual host configuration in Nginx or Apache or whatever. So you'll say, when I get a request in for this host name and this path, then this ingress object should go through to this service, which is the backend, and then that'll go to one of the pods. And then the ingress resource is picked up by some ingress controller. There's a number of them, Nginx, or there's one called Traffic or Traffic. I pronounce it Traffic or Traffic. And it'll pick those ingress objects up, and then it'll have its own load balancer or node IP that makes it publicly accessible. So this is the thing about Kubernetes, that has a very powerful API that you can use to monitor things, and that's how something like an Ingress controller would figure out how to set up its configuration. So then you have Stateful Set. So a Stateful Set is basically when you have an application that needs to keep its own persistent state on disk. And the reason that's distinct from deployment is it will at will destroy and create new pods. And the only way to have, you couldn't have multiple replicas in a deployment that have different state. And any pod can be deleted at any time. So you can't really rely on deployment for something that requires state, like a database. So typically what you'll have is a stateful set for your database and a deployment for your web app, which has no state of its own. Stateful set gives you guarantees that you don't get in deployment, like the order in which pods go up and go down. It guarantees you that that storage you get allocated is allocated to the same pod every time. So the way storage works leads into persistent volumes and persistent volume claims. So typically what you'll have is a stateful set will create a persistent volume claim for each pod in the stateful set. And that claim then back on the inside, this is another component, it's not listed here. You have a storage provisioner, and the storage provisioner uses the Kubernetes API. It sees these claims, and a claim will contain a request for 8 gigs of storage, let's say, and then the provisioner will go off and find either an existing volume that it was previously kind of matched up with, or it'll create a new volume, and that's this persistent volume object, and that's the actual storage, which can then be mounted into the pod. So stateful set and deployment are kind of they manage pods, and there's you specify what the pod's kind of template should look like, and the stateful set also manages the persistent volume claims. So those are the kind of, as far as I know, the most important Kubernetes objects. There are a lot more. I'll get over to that as well. So then if you want to follow along, we're going to need a couple of things. So first of all, you need kubectl, which is the command line tool for managing Kubernetes and Kubernetes deployments. So that's just a quick and dirty way to install the binary on your machine. If you look at the instructions, they explain how you can install it from your package manager and stuff like that. I'm not going to go through all that, and I already have it installed. And then, so K3D, this comes back to the number of moving parts in Kubernetes. So you have storage provisioners, ingress controllers, wiring up the networking, all this kind of thing. So when you're doing a production deployment, it's rare to actually install all these individual bits yourself. You'll usually use some kind of tool that sets everything up for you, or we'll use something like K3S, which is what I would describe as a distribution of Kubernetes. So K3D then is basically running K3s inside, you can see there, K3s inside Docker. So this basically allows you to create a Kubernetes cluster where each node is like its own container, basically in Docker. There was there's another tool that I think you'll probably see mentioned a lot called Minikube, and that basically allows you to create a Kubernetes inside a VM, but it's only one node, and it typically uses virtual machines, which is kind of unnecessary when you can just run them in containers. I think you can set up Minikube to use containers. It's been a while since I've looked at it, but we're just going to go with K3D because it uses K3s, which also gives us some nice things to start with. K3s, I think, yeah, I'd call it an opinionated distribution of Kubernetes. So it comes with an Ingress controller, for example. So, yep, they have an install script for K3D. I've already got it here. I think you can check their guide. It just installs it in user local bin, I think. So then to create a cluster, so K3D has its own CLI. We're going to do K3D cluster create. And if we look at, there's a whole load of options here, most of which we're going to ignore. But the command I would suggest here is this. So let's see, K3 cluster list. So I already have a couple of clusters from before. I'm going to stop my previous one. And I'm just going to create a new one. Let's see, create. Let's call it epic. And then so the parameters I'm specifying here are servers 1 and agents 3. So typically in Kubernetes, your master nodes, they don't actually run any workloads at all. They only have the Kubernetes backplane, which is the database, the API server, scheduling, that kind of thing. And you have these worker nodes, which actually run your deployments. So K3s uses slightly different terminology because it's not quite the same. They have servers and agents where a server is like your master and your agent is your node, but masters can also run workloads by default. So yeah. But in this case, I'm just going to say, let's create one, where is the command? One server and 3 agents. And then this last bit here is basically going to expose port 80 on the load balancer. So K3s and K3D provide so typically, again, when you're deploying Kubernetes, you need something to provide public IP addressing in load balancers. And K3s basically gives you one which just exposes, it's sort of like node port, but node port it has some other limitations. So basically the load balancer they provide just exposes it on all of the containers. And then this bit here basically just says open port 8080 on your own machine, local host basically. And then port 80 internally. So that's going to be K3D provides an Ingress controller, and that's what we're going to mainly use to access the services. So we're just going to expose that so we can access it. So I'll just paste those in. So now it's just going to create each of these containers. So if I look at Docker, you can see it's creating Docker containers. Just wait a second while it gets those ready. Okay. Now, typically what would happen here is it would also generate you a kube config, which basically tells kubectl how to talk to your cluster and how to talk to the API server basically. But because I have a whole kind of funky setup with multiple configurations, it hasn't done that, and it hasn't overwritten my existing config. So what I'm just going to do is k3d kube config get, and then the name of the cluster, which is epic. So you can see this is what a kube config file looks like. You have the cert. This is it. The Kubernetes API runs over HTTPS, so it's just to verify the certificate. And then you have a client certificate and a client key. So this is just for authentication to access the API. So I'm just going to put that in temp k3d. I'm going to set my kube config file. So normally you could just go straight to this step. It'll write your kube config file for you. So then what you're to check everything's working, then you can do kubectl get nodes. And then you can see here, there are all those nodes that we have. So another thing I'll mention is, because I be running the kubectl command a lot, I have an alias just k, so I can just do k get nodes. So I'm just going to use that, but it's just kubectl. So then just a brief overview of the CLI. So it has, you can see here, a number of different commands. The typical ones you'll use are, you might use create at the beginning, but then beyond that, you won't really use those. Once you understand the YAML, you won't really use create, expose, run, and set anymore, as it says there, beginner. What I'll find myself using is get quite a lot, and that allows you to just print out the state of, or the object inside Kubernetes. You'll probably be using logs, describe, exec maybe, sometimes port forward. Those are the ones you'll typically be using. So what we're actually going to do now is deploy something. So to get started, we're not going to look at the YAML. We're just going to create things using those beginner commands. So I'm going to use kubectl create deployment test, and then we specify the image. So this is behind the scenes going to create the deployment YAML, and have a pod template and all that stuff. And then if I add port 80, I think that just adds the port to the deployment. It doesn't create a service. Yeah, so we can do that later. But if I do that, then it says deployment is created. So now if I do k get deployment, you can usually shorten it. The full thing is like deployments.apps. You can just do k get deployment, and you can see I have this deployment now, and it says it's ready, up to date, available. And if I do then k describe deployment, so it'll be k get deployment, and that'll show you a list of all the deployments. You can also get an individual one, so k get deployment test. So that'll just show me that one. Obviously, in both cases, it's just one because I only have one deployment. And then I can also do k describe deployment test. And you can see here there's a whole load of stuff. So the name, there's the namespace, there's labels, here's this pod template, there's the image I asked for, the port I talked about, and you can see here all the events as well. So it's scaling up. So this is the deployment, not the pod itself. If I do k get pod, you can see there's a pod here. So I didn't create that pod myself. The deployment did, and you can see it has this kind of funny name, and that's just part of how the deployment is managed. You can see it's ready, it's running. And if I can do describe again, so k describe pod test, and you can see here it's controlled by replica set, which is another small layer of abstraction, but you'll see here it has an IP address. So there's that IP, then that's a cluster internal IP. There's the port from before, the image. It's a service account. You don't have to worry about that. And then you can see the events here. So this is when it starts up. These are the things that it's doing. So the scheduler assigned the pod to a node. So you can see it was assigned to one of the nodes. The image was pulled. So kubelet is the process on the node that manages the deployment. So it pulled the image, created a container, and started it. And now, yeah, so you can see there it's running. So now how would we actually access that? So we can't actually get it into the cluster network directly. So what we're going to use is a command called port forward. So port forward allows you to access a pod's port, and it forwards it to your local machine. So I'm going to do kubectl port forward, and the pod is, what's it called? That. So I think, yeah, I have that explained here. And then I'm going to do, let's say, port 8081. So we're using port 8080 already. And then I'll forward that internally to the pod's port 80. And now it's running this. So it's actually forwarding requests in user space. So if I do curl localhost 8081, you can see this. So this is basically the image I'm using. If I look it up, this is just a very basic, like, kind of test image that prints out some information. So you can see this is the host name, which is the same name as the pod. And then these are all the IP addresses it has. So you can see there's that cluster IP. And then this is just the request that we sent, the remote address. So that's great. And you can see there it handled the connection, it proxied it through. So that's fine. But now what if we want to do the load balancing? So what we're going to do is create a cluster IP service. So the service will get its own IP address, which will load balance, but it'll still be using a cluster IP. So if I go k create service, and then the type, so if I do k create service, you can see there's cluster IP load balancer node. I'm actually not entirely sure what external name is. I suppose it's probably something to do with DNS. But we're just going to use cluster IP for now. Service cluster IP. And again, there's nothing magic about these create commands. They're just generating YAML, and I'll show you that later. So we're going to do k create service cluster IP, and then the name is going to be test TCP equals 8080. So let's just check the help on that. So that basically says this is the name of the service, and then I want to have port 80 on the service go to port 80 on the pods that are referenced in this service. So let's do that. There's the service. So now, if I do k describe service cluster test, so you can see now here's our service, and you can see that it has its own IP address again in the cluster space, and there's this port 80, and then its target is port 80, and you can see there's this endpoint. So that, if you remember from earlier, is the cluster IP of the pod itself that we had before. You can see there's only one endpoint because we only have one pod. So if I okay, so you can actually then, I don't have it listed in the guide, but what you could actually do then is port forward to the service. So if you do service / instead of pod / and then the service is just test, then again I can do curl localhost 8081. And you can see it works. However, and the next thing then would be, let's scale it and see the load balancing, right? But the problem is that port forward, while you can port forward into a service instead of a pod directly, internally, this is something that tripped me up initially, but internally, it will always just forward directly to the pod. So in order to see the load balancing, we're going to have to actually create an ingress so we can externally access the pod. So if I go to k create ingress, and then we look at that, so you can see there's a whole lot of explanation here. But basically, if I go k create ingress test, now you have a rule. So again, this is like your virtual host, or whatever you want to call it, a configuration for another HTTP server like Nginx or Apache if you want to use Apache. So basically the syntax they have here, again, this just translates to YAML, says, so this host, so I'm going to say, whom am I? Who am I? And then the path I want to match is just anything. And then the service that we want this ingress to connect to is test, which is the one we created earlier. And then the port on that service is port 80. So it's pretty standard stuff if you've worked with Nginx or whatever before. Host star. Oh, I put the equals in the wrong place. There we go. If I actually, yeah, if I never did this earlier, but if you do k get service, you can see there was another service before, which is for accessing the API itself. The Kubernetes API, that is. There you see there's our test service from before, the cluster IP there. And if I do k get ingress, you can see here is test. The hosts are who am I. So that's the service reference. Actually, I think Kubernetes. Well, let's do k describe test. Describe ingress test. So the default backend is this default backend colon 80 endpoints not found. Not sure why it doesn't say that. There is backend there, and you can see that's the pod's address there, the endpoint. So test 80 is the service, and then so I think I might have brushed over it, but when you create a service, that DNS name becomes accessible then inside Kubernetes. So if I do a DNS lookup of test is the name of the service, and that will resolve to the service's IP. You can also set it up to do DNS round robin if you want. So now that we have an ingress, Traefik will actually respond to that. So if I'm going to do something here, or if I do k, so Kubernetes has these namespaces, which are how you can group different distinct parts of your deployments together. So kubesystem is like a standard one, and that contains some system stuff. So in this case, there's Traefik, the let's get pods. So you can see here that's the actual Ingress controller, Traefik. And then you can see here you actually have this load balancer type service. So this is pointing to, if I k describe namespace kube system. I know I'm kind of brushing over this, but it's not that important. It's just to show you that it's all just the same stuff. There's nothing magic going on with the Ingress controller. So if I describe service Traefik, you can see here that well, first of all, it exposes more ports. And the external IP address there listed is this internal one. But if I look at my IP addresses on my machine, somewhere in here is this bridge. I think that's the one. Yeah. So obviously this is the network that the Docker containers are on. In a standard cloud deployment, this external IP would be a real IP address. In this case, it's just a local virtual one. So then you can see this is that port. So this service is set up to expose HTTP and HTTPS, of course. And these are node ports here. So the load balancer internally uses node ports. And those ports then are, as I said, exposed on every node. And those wire through into a real pod. So you can see endpoints there. If you look at the pod, I'm not going to go through it again, but if you look at the IP address of the Traefik pod, that will be it there. So that's that endpoint. And you could also deploy multiple instances of Traefik then for more load balancing. And then it has its own service IP as well. But earlier, since we created the K3D deployment with port 8080 exposed and that this is proxying through, forwarding through to port 80, I can actually curl localhost 8080. You see it's 404, and the reason it's doing that is because we created the configuration for the Ingress matching this who am I rule. So what I've actually done is, well, first of all, just to show you straightforward, I've just going to set the host header by hand. So typically, when you send a HTTP request, as part of the request, you set the host header, and that's how HTTP servers know, this part that you're trying to reach in the URL. So I'm going to do curl and set the host header by hand. So who am I matches the rule that we had before. And you can see now that we are in fact hitting our service again. And this time we have some HTTP proxying. So Traefik has added in these headers. So the real IP address that's of the client. I suppose this is probably X forwarded 410.42.06. This is probably something to do with K3D. Normally, this would be the actual IP address of the client. It's there. You see there. This is the server that matches the name of the pod that Traefik is running into when it's doing the proxying. So now that we have the Ingress, let's actually try some multiple replicas. So if we use this kubectl scale command, this is again setting some YAML values that we'll look at shortly. But if I run this, it's going to change the number of replicas in the deployment. And if I do kget pod, now you'll see that there are more containers here. So we've set the desired state of the deployment to have 3 replicas, and now it's going and doing its best to make that happen. So if I do kget deployment, you can see here now it's got 3 out of 3. And they're running and all good. So now if I do K3, so now we've got multiple pods. So now we can actually see the load balancing in action. So if I do hit this, you can see there's the IP of the container. If I do it again, this is different. And the host name is different. So you can see we're actually getting load balanced into different pods now. So if I do kget pod, you can see those are all the different host names we have. And if we go back to the service and we describe the test service, now you can see we've got 3 endpoints. And those are all those IPs we're seeing. So the service is finding all those pods, matching by label. I'll explain that in a minute. And so now we've got multiple endpoints that it load balances to. And yeah, so that's pretty much it. That's what I'm going to go with for the deploying without looking at the YAML. You can delete all this stuff. I'm just going to leave it because it doesn't matter really for the moment. So now what we're going to do is try and deploy WordPress as a Kubernetes service, the Kubernetes deployment. A small caveat, WordPress doesn't entirely work the way I've set it up because I'll get to that actually. It'll be easier to explain. So basically we're using the standard WordPress Docker image. So I'll basically explain how you might set up something that's analogous to this Docker Compose file that they give you where you have your WordPress, you set the environment variables for configuration, and the same for your database then. So basically what I've done here is I've separated these out into 3 different YAML files. So the first one we'll look at is let's have a look at the app first. So I've actually got multiple YAML documents in here. So if you've worked with YAML before, you might not know that you can actually put multiple YAML documents in one file using this triple dash to separate them. So you can see here I've actually got 2. And Kubernetes is fine with those. It'll just apply each in a row. So then, now that we're here, let's go and explain the general format of Kubernetes YAML. So typically what you'll see are 4 different top level fields. API version. So this is the version of the API, Kubernetes API that you're using, and there's usually a specific part of it. So apps v1, I think is that. Yeah, so there's different parts of the or sections of the API. And I'm just going to open up. There's a huge document here, which is the reference to the entire Kubernetes API, which is going to take a while to load. But I think, is it here? Yeah. So you can see here that these API groups, and I think the way it works is you specify group and then version with a / in between. So I think core, if you don't specify it, it's core by default. But I had in the YAML here, you can see it's apps v1. So the API group is apps and the version is 1. So this is if you're curious and want to check all the parameters that you can set. So this is a deployment, for example. But typically all Kubernetes objects will have the same structure. You have this API version, kind, which is the specific object type within this group. And then you have this metadata section, which first of all, you have the name of the object. So everything obviously has a name. You can also have a namespace, so you can separate things out into different namespaces. If you don't specify a namespace, it's just there's one called default. So you could specify that there if you wanted to change it. You can also override it on the command line if you like. Then you can add these labels. So labels are what allow you to, you can filter things by label, and that's how the deployment and the services work. I'll get to that. And then you'll have this spec, which is the actual description of the thing that you want to create. So let's actually head over to the API here. So you can see here, there's the version, the kind, metadata, spec, and status. And status is then, this is filled in by Kubernetes, which says what the status is. So the spec for a deployment, there's a whole load of things here. Well, actually, there's not that many, but the main thing, first of all, you can specify the number of replicas. So this is that scale command. When you run scale, it's just changing this number. So 1 just means we'll have only one pod at a given time that's running. Now selector, this is already, we're coming to this labels thing. So basically the selector says, well, how are we going to find pods that belong to this deployment? And we'll see we have a match labels. And again, if you want to see how all these work, you can have a look here. There's all different ways that you can. Oh, look, there's only 2. Match expressions, match labels. I'm not sure how complex that is, but typically you'll just want to do this. So we're basically saying any pod that has the app is WordPress label that belongs to this deployment. And then this template here, if you go back to the API, template is a pod deployment spec. And you can see here, this appears in a bunch of different places. So if I look at pod, it's not showing there. Pod spec. I guess it's slightly different, but it's basically what you've got here is something that's almost identical to, oh, it is, yeah, sorry, there, pod spec. So pod template has specific metadata. Yeah, it's slightly confusing, but you can see it's referencing the same thing, pod and pod spec. So it's the template references the exact same object. So you're literally having an inline pod. That's why I put this label here. So this is the exact same as if you were to create a pod by hand, but you'd almost never want to create a pod by hand. So this deployment will create pods of this type, and then it'll match them against this label so that it knows that those belong to the deployment. So the main thing that you'll have is containers. And again, it's containers because a pod can be made up of multiple containers. So what we've got here is the WordPress one, and we're using this image. So this pod spec is similar to, your this part here of the Docker Compose, if you're familiar with that. So we have the name of the image. It's just WordPress. And then environment variables. So we can set environment variables, but we can do some magic here that you can pull environment variables from all sorts of different places. So you can specify their value directly. So we're going to say the database host is wp-db, which is the name of the WordPress database service, which I'll come back to. Then we have a database user, and you can see you have this value from. So let's see, if we go to the pod spec, container array, and then we have env, and you can see we can have a value which is direct. So each element in the variables is either a direct value or it has a source. So you can see there's all different places you can get the value of a environment variable from. So that's what we're looking at here. So this basically says config map ref. So it says take the value from a config map. So, well, how do config maps work? Well, I'll come back to that. But basically, this says I'm referencing a config map that's called WordPress DB, and I want to take the value. A config map can have multiple, it's basically key values in YAML. And you can say, well, I want this environment variable to have the value of the key user from this specific config map. And then I want to set the password. And this is pulling it from a secret, so secret key ref instead of config map. The only difference from config maps and secrets is that secrets are supposed to be stored encrypted. I'm not sure if there's any this is the distinguishing feature there, so that I think the implementation could be slightly different. The only actual difference when you're creating the objects is that the passwords are encoded, not encrypted, in base 64. But I'll show that in a sec. And then so there's another reference to the same config map. And then the ports, again, this is analogous to the port section of Docker Compose. Yeah. So, but in this case, ports doesn't actually do anything. It just says, well, we have this port on the container and it's called, we're going to give it a name. We're going to call it HTTP and it's TCP. I think there's probably some other stuff you can add there. We have this thing called a Liveness Probe, which if I look at k get pods again, this ready thing here, after the pod is created, the Kubernetes will periodically check, it's like a health check, to make sure that the pod is up and running. So in this case, I've set it to perform a GET request on port 80 in the container, and the path is /. So just try a GET request, and if that works, then it's probably up and running. So then you can see here, just for the sake of demonstration, I've added a second container, a sidecar, and it's just Alpine sleeping forever. So it doesn't actually do anything. It's just an example. And then you can see here, I've created a companion service. And so you can see we have the same API version, v1, so this is in core. And then the kind is a service, has the service is called WordPress. It has the label app is WordPress. And then the type is cluster IP, so there's different types of services. The selector is on labels, and the label we want is app equals label, or the app equals WordPress. And then the ports on the service are HTTP, and the port is 80. So this is the port incoming on the service. It's in TCP, and the target port is HTTP. So that HTTP there is referring to this HTTP described in the container. So I know there's a lot of abstraction going on, but it might be difficult to see the usefulness of all the layers. But when you're deploying things on a big scale, it helps a lot. So we've got all this YAML here, and just to show you that when you do Kubernetes kubectl create and then service, it's not doing anything magic. So if I do k get deployment, I'm going to do k get deployment test, and I'm going to add -o YAML, and that's going to print out the YAML that represents this. So you can see there's the status, but here's there's also some extra metadata that it likes to put in, but you can just ignore that. But you can see here there's a label, the app. There's the name and the namespace. And here's the spec. So you have 3 replicas, selector, matching, label on app. There's a template, there's a container. The name is who am I, there's a port 80. So you can see it's exactly the same. And if I look at the service then you can see there's our cluster IP. So you wouldn't set these by hand. Typically you can specify if you want a specific IP, otherwise Kubernetes will allocate one for you. So you can see here's the port. In this case, it's just called it 80-80. And then the target port is 80. And then the selector is on that label, test, app equals test. Yeah, so that's it. And now let's have a look at well, actually, first of all, let's just deploy that now, actually. So if I do Kubernetes kubectl apply -f, I'm on the right directory here, am I? kubectl apply -f, so that means apply. So apply basically says, oh, I have this YAML and I want to apply the state into the cluster. So these will actually merge into, if you have the deployment is already there and you do apply, it will update and merge into the existing deployment. It won't, that's why it's apply and not create or delete. So let's apply app.yaml. So now you can see it's created the deployment and the service, which are the 2 things that were in this app.yaml. So if I do kget deployment, you can see WordPress is not ready. And if I describe deployment WordPress, you can see there's a description of everything. Now, it doesn't seem to say here, but the reason that this isn't ready, so yeah, there's the pods, right? So it's created a pod, and you see it's 1 out of 2 of the containers is ready. And there's an error, and the error is because the config map's not found. So it's actually not going to go up because we're missing that config map, and it needs that. So that's actually in a different deployment file, db.yaml. So here's the config map. Again, same thing. It's got an API version, a kind, metadata. This is the name of it. And then data in this case instead of spec. But this is where you specify those key values. So you've got database and user. So back to here, you can see we're referencing this WordPress DB config map. And the key is user. So that's this. So the value will be WP. And the value of WordPress DB name will be WordPress. And then you have the secret. Again, these are encoded, not encrypted. It's the same structure other than these base 64 bits, and the kind is secret. So if I do base 64-D, you can see we have a very secure password there. And then, so for the rest of this, we have a stateful set. So the kind is service. We have a service. And again, it's cluster IP. And this time we're selecting WordPress DB as the app. And that matches the template here for the stateful set. And we have a MySQL port, and the port is 3306. And protocol is TCP. Target port matches MySQL here. So now you'll see that we have a stateful set. And stateful set, generally overall, it's very similar to the deployment spec. So you can see we have these replicas and template. And there's a pod template again. And so we have, in this case, just one MariaDB or MySQL container as the image. And then we're specifying the environment variables in the exact same way. But we also have this extra bit at the end, the volume mounts and the volume claim templates. So stateful set will also create persistent volume claims for each replica in the stateful set. So that's what this template is about. So this again is referencing a persistent volume claim. It's the same spec. So we have one called data and the spec here. Access modes, don't need to worry about it too much. Read, write once basically means that only one container at a time can actually have access to this. and then we're requesting 2 gigs of storage. And then volume mounts say, well, so there's going to be a volume, persistent volume called data. And we're going to mount that to varlib MySQL. So if you look back at this, you can see here, we want to have that mounted in varlib MySQL. So that's pretty much it. If I now go and k apply -f WordPress DB, see it's created all those different things. And now if I do k get pod, so you'll notice here as well with the WordPress pod, you can see that all these errors are, you see it says x7 over x amount of time. So you can see it's constantly trying, and it'll back off. It's constantly trying with ever increasing backoffs to get the state into the state that we want. So you see it's tried like 7 times. It'll eventually get there. Yeah, so it's up now. Now that we have the config map, so there's the config map and the values. So like we can look at that config map if we want. So there's those database, WordPress, user, WP. So now that that's there, we can see that our WordPress deployment is all happy. And if we do k-get stateful set, you can see we've got our WordPress DB. So if I go k-get pod again, you'll notice that the WordPress DB pod is named differently, and that's because of the way is this last bit here is increments from 0 and 1, 2, depending on how many replicas you have. And that's just the way, again, that stateful set manages and schedules pods differently. And if I also do k describe pod WordPress DB 0, you see we have the volume there, persistent volume claim, and there's the name of the claim. So if I do k get PVC, you'll see that the stateful set created this persistent volume claim, and it's bound. So it's bound to a volume, and a persistent volume called PVC, blah, 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 auto-generated. And there's the capacity. So if I do k get PV, there's that matching volume that was created. So now we have everything ready. The only thing we're missing is a way to get into WordPress. So I've created an Ingress. So this is what Ingress actually looks like when you're not using the create Ingress command. So again, it's similar. Kind, metadata name, spec, rules. So there's actually quite a lot of syntaxing going here because again, there's quite a lot of things you can configure in a HTTP proxy. So we're just using very basic. This is the host we're matching. It's HTTP, and then we have a single path here, /. It's prefix, so everything after it, and the service we want to go to is WordPress, and the port on that service is HTTP. And again, actually, if I go k get deployment, k describe, or k get deployment WordPress-o YAML, you'll see that this all matches the YAML that we had. It's just added a couple of extra things, like the status and all this crap here. So now that we have the Ingress, or have I applied it? Yeah, I did. So there it is. Describe Ingress test. No, that's not. No, sorry, we don't have the Ingress. We need to. That's the old one. So okay, apply -f WordPress front end, and let's create that Ingress. So now we have our backend as that named port that we had before. So now what I can actually do is, okay, so I'm going to go this into my browser. What I've actually done is I've added an entry to my hosts file to localhost just so that I can put WordPress into my browser. Because if I do localhost 8080, it's going to give me a 404 because we're matching on the WordPress host. So WordPress 8080. Okay, so my browser's caching the wrong port here. I'm just going to open an incognito tab. So English UK, blah, 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 test, bro, hunter2. Let's use that password. Grand. Okay, there we go. And there we have WordPress. So yeah, there we go. And now I'll just show you a couple of things. So first of all, let's actually get into one of the pods and take a look around. So if I do k-n or no, k exec, this allows us to run a command inside a container, inside a pod. So if I do k exec WordPress, let's have a look inside the WordPress pod. And let's run bin ash. Okay, so here's something that we have. So exec, well, see it says it's deprecated because you actually want to, actually that's not the reason it's deprecated, but you can see here it says defaulting container name to WordPress, and that's because, you know, there are multiple containers inside the pod. So let's use UK describe pod WordPress. You can see that is on the wrong port. WordPress is screwing me over here by trying to redirect. What I'm actually just going to do is WordPress app. It's trying to redirect this. I'm just going to get rid of the Liveness Probe. So this is actually a good demonstration of making a change. Just if I change that now, and if I do k apply -f WordPress app, you can see the service didn't change, but the deployment is now different. And you can see what's going to happen is, so right now what's happening is this is restarted because the liveness check failed because WordPress broke it. What's happening is that container is left running while it's creating the new pod that satisfies the changes that we made, which is to remove the liveness probe. So now you can see that now that this is up and running and it's all happy, it's terminating the old one. And that all happens transparently. So now if I do k exec, so something then what we need to specify is if you do k exec by default, it goes right into the goes into a default pod. But what I want to do is go into the sidecar pod. So the pod or the sidecar container. So yeah, the container was called sidecar, I think. So oh no, container not found sidecar. Why is that happening? Oh, this is probably a K3D specific thing, actually. I'm not entirely sure where that's not working. K exec, K describe pod WordPress 6 blah 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 containers. I'm not sure. I think this is probably something to do with the fact that it's running in K3D. Maybe you're not able to do this. I thought I was able to do it before. Oh, it worked that time. Okay. I'm not sure what's happening there. Maybe the container wasn't fully up. But this is similar to Docker exec, if you're familiar with that. So if I leave this out by default, first of all, Okay, yeah. So see, it says here defaulting to container name WordPress. So if you don't specify the container name with -c, it'll pick the first one. So I'm just going to go with sidecar, since that's the Alpine one and has the commands that I want to use. So first of all, you can see here, there's the pod IP. And if I go into the WordPress container and use bash, then, because I think that's what's in here, you can see, oh, first of all, we don't have, okay, we actually don't have IP or ifconfig, but we would have the same IP because it's running within the same pod. So there's our IP. And then, so how are we communicating with the database? Well, the host we set was, what was it? I think it was WPDB. Yeah, there we go. I guess ping isn't working, but see, it's going to this IP address. And it's going to use that every time. And if we go back out and k describe service WPDB, you can see that's the IP address of the service. And then if we try to connect on this port, it would proxy to the actual pod. So this is that DNS part, and that's the host that we set that WordPress would actually talk to the database through. So that's how that's working. Now let me go back to my notes. Okay, yeah. So let's scale the deployment. So we can use the scale command again. Deployment, then WordPress replicas 3, and scaling it. So now if I do k-get pod, you can see there's more containers coming up. And if I do k describe deployment WordPress, you can see the replicas is now 3 desired. And if I do k-get-o YAML deployment WordPress, we'll have a look at the YAML. You'll notice that all the scale command has done is just set this replicas value to 3. So again, nothing magic going on. So now we have 3 replicas. And if we hit WordPress, I can't really show you. Is there any way for me to show you here? Don't think so. You can't actually tell, but this is load balancing. So this is one of the problems with doing WordPress like this, is that this part will actually fail because WordPress stores part of its state inside its own PHP and not in the database. If I try to log in, this is probably going to fail. So yeah, you can see it's just dropped me back at the login page, and that's going to keep failing because what's happening is I'm logging in, it's setting the cookie, and then it loads the next page, but that's on a different host, and it's all confused because it's a different backend. So there's your proof that load balancing is working between the 3 instances. And that's pretty much it. So then what I can actually do is to delete everything. I can use this command here. And you notice I'm using the YAMLs, and basically Kubernetes will use the names. It'll match on the names. If I just pull back my old window here, it'll match on the namespace and the name and the metadata here to find out what it needs to delete from these. So if I do k delete, service error when deleting front end YAML. WordPress not found. Did I? Oh, I specified WordPress. I specified. It's a mistake in my README there. I deleted front end twice. Let's try that again. Yeah, so now it failed to delete those previous things because they were already deleted. But now you can see that if I try to reach WordPress, that's not going to work. It's going to 404 because the server, HTTP server, traffic is still there, but the rest is not. Now, if I do kget pvc, you'll see the volume claim is still there. The data is still there, but all the actual pods are, well, they're being gotten rid of. If I do k apply, I think do I have the whole command? If I change this delete to an apply, see it's recreating all those things at once. And that's, if you add -w, you can watch it and it'll update as the state changes. So it looks like everything's up and running already. So if I reload, yeah, the site's back. So totally new deployment and stateful set and ingress and the whole lot. But because the volume was already there, the stateful set matched, and the persistent claim was already there. The stateful set yoinked this volume in and mounted it, so all the database state is still there and the website's still here. So that is, I believe, it. I know it was a long one, and I kind of blitzed through it, but hopefully that was helpful. So I think this is the first in a 3-part series on Kubernetes. So if this is interesting, then the next part will be about some of the more advanced stuff in Kubernetes and that you might want to do. So I haven't entirely decided what it'll be yet, but something we'll definitely be looking at is Helm, which is a kind of a package manager for Kubernetes. So the problem with these YAML files is they have a lot of the things set in them, like the stat values and the config map and things like that. But you might want to, have a convenient way to deploy all these different components of an application with one command, and you have a centralized YAML file that basically allows you to configure different parts of it, like what ports or whatever that it'll use, or configuration things. So yeah, I don't know. We'll see. I might describe some other cool add-ons. The Kubernetes Dashboard is quite nice. We'll probably go with that. GitOps is a kind of a buzzword these days that we're using here at NetSoc. And then the last part will be about deploying Kubernetes on an ARM cluster. So we got these. See, I'll show there. We got NetSoc got a sponsor, sort of. This company called Friendly ARM sent us out these boards to demonstrate Kubernetes running on a cluster with. Yeah. We'd like to thank our sponsor. So use code NetSoc at checkout to get 0% off. So yeah, we'll be putting Kubernetes on these. We've got 8 of them. I bought 4 of them myself. So hopefully we'll have all 12 of them running, and that'll be pretty cool. So you can see each one of those will be a node then. So instead of only these 4 container nodes, we'd have 12 big real life ARM nodes. So yeah, that's pretty much it. Thanks everyone for coming.